Okay, we're going to do a Dalton's Law example problem. So what we're going to have is a vessel, and it's basically two flasks that are connected together. I'm just kind of drawing a diagram of it. It's not what it really looks like. And in one vessel, we have 275 mils of helium gas, and it's at a pressure of 752 torr. And in the other one, we have 475 mLs of argon, and it is at a pressure of 722 torr. All right, and now we're going to remove the barrier between them, and those two gases will mix. That one will go into there, this one will go into here, and they'll mix completely and completely fill that entire vessel. And we want to know what is the total pressure. Total pressure after mixing. So we have two flasks, we combine them together. We want to know what that total pressure is. Okay, first thing we want to do is find out what's the total volume, okay? Because we had two separate flasks and now we have one big flask. So what's the volume of that big flask? So the total volume, this is easy, but we have to do it. 275 plus 475 is equal to 750 mLs, okay? So now what we need to do is that helium, it is going to expand to completely fill that 750 mils. We need to figure out what its new pressure is, and then we'll do the same thing for argon, and then we'll add them together. So that helium, let's just get it down here. We have a pressure and a volume. We have a new volume, and we want to know the pressure. So this is Boyle's law, P1 V1 equals P2 V2. Notice there's no temperature here, there's no moles here. We couldn't find those things even if we wanted to. Okay, so we want to find the new pressure. The new pressure is P2. So P2 is equal to P1 V1 over V2. And this gets confusing just because of all the P's and V's and stuff. I know, but just stick with me. We'll just plug in numbers here, 752 torr. These are just coming right off the problem up above. Our original volume was 275 mils for the helium, all divided by 750 ml. And we get a P2 here of 275.7 torr. And notice it didn't matter that I used mLs and torrs. It doesn't matter what my units are. They're the same on both sides, so that it just works out. Okay. And I'm going to rename this. Instead of P2, I'm going to call this P sub HE, because that's the partial pressure of helium. All right. Now, let's go back up. We want to do the same thing for the argon gas. Okay. Same exact equation, same scenario, P1 V1 equals P2 V2. We're going to mix them, so P2 is equal to P1 V1 over V2. That's exactly the same way we started for helium, nothing new. Okay, plug in the numbers, and we have 722 torrs, which, by the way, a torr is the same thing as a millimeter of mercury, 475 mLs, new volume, 750 ml. That works out to be 457.3 torr, and I'm going to call that P sub argon. So what I've just done is I've calculated, first off, for this guy over here, if helium was alone in the vessel, without the argon, and the vessel is 750 milliliters, it would have a pressure of 275.7. And if this argon were alone, that would be its pressure once we remove that barrier, okay? But the problem asked for the total pressure. So Dalton's law of partial pressures says P total is equal to P HE plus P AR. All we got to do is add 275.7 torr. And by the way, these do have to be the same unit. You cannot add torrs in, say, atmospheres. And 457.3 torr. And that works out to be 733 torr. And that's it.